Good morning, good afternoon, hello, good evening, whenever it is you're watching. We are talking about electronegativity and types of bonds. This is not in your packet. This is just an extension of yesterday's lecture, okay? I didn't like the way that it related electronegativity and how different types of bonds form. So we're going to elaborate today and we're going to discuss to see exactly how electronegativity and bonds and the type of bonds that form because of electronegativity. Okay, so this is not part of your packet. It's just an extra lecture. Okay. Yesterday we said, is it easier or is it hard for you to make new friends? Now, for some people, it is really easy, right? It's really easy to make friends because they're really good listeners, they're really funny, there's different reasons why people get attracted to certain people. Maybe they're into the same things that you are. um but there's always something that pulls a person in and creates a friendship with certain people, right? I know for my husband, he likes his friends and they're all gaming friends, right? They talk just about every single night when they're playing on the PlayStation. That's just them. For other friends, it's just because, they're really, really funny and that's how come I like to hang out with them. And then I have another friend who's really, really good listener. So there's different reasons for your different types of friends, right? And just like elements on the periodic table, there's certain elements that will pull these electrons into closer to it, just like when you make a friend, when you have your best friend, there's something that draws you close to them. And the same thing happens here with electronegativity. There is a reason um, why you're attracted, or those electrons are being pulled closer, because the electronegativity, the strength of that atom is really, really high in electronegativity. Okay. Now let's review what electronegativity is. It is a way to show how strongly an atom attracts electrons from other elements. The difference between the electronegativity values for two bonded atoms indicates how equally they share the bonding electrons. And there's three types of bonds that we're going to be talking about. And I know they're really, really small pictures, but the first type of bond is known as an ionic bond. This is where electrons transfer from one atom to the other. And you can see that their clouds are completely separate. And the reason that they come together is due to an electrical attraction between the positive atom and the negative atom. That is what holds it together. In the case of a polar covalent, this type of bond, instead of transferring electrons, electrons here are shared, but they're shared unequally. And you can see how unequal the sharing of electrons is, because you can see that this orbital, this cloud, is much bigger than the cloud for the blue atom. Okay. This time they're sharing electrons. There's not transferring of electrons, but they're sharing it unequally. 75% of the time, it's this yellow atom or gold atom, and then 25% of the time is with this blue atom. Okay. Uneven sharing of electrons. And you can see a bigger example right here. In the case of oxygen and hydrogen, the electrons are pulled closer to oxygen, creating a partial negative charge, and hydrogen has practically given away its electron, giving it a partial positive. Okay. It's not completely positive and it's not completely negative. It is partially positive and partially negative, because those electrons are still shared, but they're shared unevenly. Okay. When it comes to the third type of bond, this is a non-polar covalent bond. you can see that the size of the clouds is almost equal because the electrons that are being shared are shared 50-50. 50% of the time here, 50% of the time over here, and equally shared. And when it comes to electronegativity will increase as you go from the left of the periodic table to the right side of the periodic table, right? The closer and closer you get to fluorine, the more electronegative you become. If you go down a group, the less electronegative you are. If you are going away from fluorine, your electronegativity is decreasing. It's getting lower and lower and lower. Okay? All right. I need some comments. Describe what is happening in this image and just tell me any way you want. Okay? I want, tell me about the colors, tell me about the atoms, tell me why is he holding a magnet. Okay? I need some comment of any type about what is going on in this picture. And we already talked about this picture. Okay? We talked about it yesterday. That's why it's coming up today. And remember, the first atom or electron is saying, I'm falling for him. And the other atom or electron is saying, he is so strong. So you can tell that these girl atoms are being pulled or attracted to the blue atom because of how strong he is. Okay? So tell me, what do you think? And if you're not going to comment here, in the response, because I only have one response, you can comment in the chat. All right, you can comment in the chat. And so far, I have no responses. Oscar Mendoza, what do you notice? And just talk to me. Come off mute. What can you say about this picture? Blue atoms, orange atoms, which atoms? Right, and it's attracting it using what? What is that thing called in a SN? Do you remember? A magnet. Very good. Yalexia, do you have anything that you can add, or what do you notice? What can you say that's maybe a little bit different than what Oscar said? Okay, so tell me in your own words. What did he say? Orange is, yeah. You can call them electrons. You can call them atoms. Either way, they're being pulled in, right? Very, very good. Anybody else? Anybody else? Anybody else? Are attracting, okay, so I'm thinking the blue is attracting the orange. Very good. Whoever this was, excellent job. All right. Let's watch a video. And this video is very, very important. Okay, and I'm sorry I could not put it in the pair deck, but it wouldn't let me. It would not let me, which is, I think that's poo poo. All right, so here you have a scale, right? And here they're saying it's the difference in electronegativity. Difference means they subtract. If you subtract your electronegative values, right? If you got fluorine 4.0 minus hydrogen 2.2, the electronegativity difference, you subtract 4.0 minus 2.2. And if your number or your answer ends up above 1.7, that's going to be an ionic bond. If it's between 3.3 and 1.7, it's going to be a polar covalent bond. And if it's between 0 and 0.3, it's a non-polar, okay? Here in a nonpolar, electrons are shared 50-50, right in the middle. Polar covalent, they're not shared equally. It's a 75-25. 75%, it belongs to the more electronegative. 25% of the time, it's with the less electronegative atom. And if it's an ionic, electrons are transferred from the metal to the nonmetal. Okay? All right, you got fluorine with an electronegativity of 4.0, cesium 0.7. If you were to find the difference, if you were to subtract, it would end up being 3.3. That is way over 1.7. That is going to be an ionic bond. What that means is electrons are transferred from atom A to atom B. Electrons are given by atom A to atom B. All right. And here you could see all of B have now a negative charge. And that actually, I think that's wrong. It should have been the other way around, right? It says here that electrons transferred from A to B, which is completely opposite of what you see here. Atom B should have been the yellow, and atom A should be in the purple. Atom A is purple and atom B is yellow, and they completely changed it here. So anytime you give electrons and you gain them, you will have a negative charge, which is what happened here to add anion B. And then you have in yellow a cation A, which is given away electrons. Okay. And there's an electrical attraction, right? Anytime you have a negative charge and a positive charge, they're going to come together because that's what charges do, especially when they're on opposite charges. Okay. All right, so here you have a polar covalent bond because chlorine is 3.0, hydrogen is 2.1. You subtract that and you get 0.9. That's in between 0.3 and 1.7, making it a polar covalent, meaning 75% of the time those electrons are going to be with chlorine. 25% it will go back to hydrogen. So think of it as going around and around and around, and then one time hydrogen, and then around and around chlorine, and then one time hydrogen, and then around and around and around. Okay? That's what we mean by sharing electrons. They're going to be sharing, it's just most of the time those electrons are going to be over there with chlorine. Okay? And that's why it's a partial negative, because it's almost gaining electrons. Not all the way. There is no transfer. They're just sharing electrons, just most of the time. Those electrons are with chlorine. Less of the time, those electrons are with hydrogen. All right, so here you have a nonpolar covalent, meaning the difference is between 0.3 and 0. So hydrogen 2.1, another hydrogen 2.1. If you subtract those, you get 0.0. That is a nonpolar covalent. So that means 50-50. 50% of the time it's with one hydrogen, 50% of the time it's with the second hydrogen, and those electrons are being shared equally. So 50% of the time they are going here and then 50% over here. And those electrons are usually considered to be right in the middle of both atoms. All right, we're done with that video. Not done yet. All right, let's talk about the type of bond that occurs. You have an ionic bond and then you have a covalent bond. Covalents can be polar or nonpolar. Polar means unequal sharing. Non-polar means equal sharing. Now, when the difference in electronegativity is high, so when the electronegativity difference is high, one atom has exclusive control of the electron, the bond is considered ionic. If the difference between the electronegativity is low, the two atoms share control of the electron almost equally. This is a nonpolar covalent. Okay? If electrons are being shared equally, like you see here, it is a nonpolar covalent. If they are shared unequally, meaning that this guy is more electronegative than this guy, then the cloud and how much time it spends, the electron, will be a lot more for this guy, this more electronegative element than this one. That is what we call a polar covalent. Okay, that just means they're unequal. They're unequal. Okay, if the difference is low, you share those electrons equally. All right. Anytime you are high in electronegativity and low, more than likely there's going to be an ionic bond. Electrons are going to be given away and gained. And over here you have another picture where you have hydrogen bonding with hydrogen. They are sharing equally. Over here you have sodium giving an electron to chlorine, making chlorine more negative, sodium positive, and then there's an electrical charge that brings these elements together. All right, we're not going to do the Venn diagram because I thought you could type it and the only thing you can do is draw. So we're going to skip this question. We're just going to talk about it really quick. What do you notice? What is the difference between ionic and covalent? What makes them different? What is happening with electrons, guys? What is happening with these electrons? Why is this arrow pointing from sodium to chlorine and there's a red dot? Somebody come off mute or type it in the chat. What is happening here when you see an arrow and a red dot that's coming from sodium to chlorine? What did I say is happening in an ionic bond? And it's all about the electrons. What are electrons doing? What does this arrow mean? Yeah, Alexia, Melissa, America, anybody? Talk to me. Irvin, what's happening? Why do I see an arrow between these two elements? Why is it pointing at a red dot or a red electron? Hello? Are you there? Are you there? The electron moved. Very good. The electron moved. It used to be over here in that outer orbital for sodium, and it transferred to chlorine, giving chlorine a negative charge, giving sodium a positive charge, and there is an attraction, right? There is an attraction between these two elements. All right. Very good. Very good. Maybe it's not supposed to be there. Yeah, maybe it wasn't supposed to be with sodium. It's supposed to be with chlorine. Very good, Alexia. Now here, all of a sudden, you see these circles, these orbitals that are touching. What is happening to these red and white dots? What is happening to these electrons? In this case, electrons moved from one element to the other. Why all of a sudden are these orbitals connected? What is happening? Okay. If you got a piece of candy and your friend is looking at you like, oh, that's so good, well, what are you going to be doing? What are you going to be doing with those electrons or your candy? If somebody is looking at you like, that looks so good, right? Oscar's eating a candy and Alexia or Melissa or Mario, you share, right? You share. That is what's happening in a covalent compound, in a covalent bond. Electrons, why are those orbitals overlapping? Because those electrons are being shared between oxygen and hydrogen. Okay? In this case, these orbitals, these circles that you see are connected because the electrons that comes from oxygen and the red electron that comes from hydrogen are being shared. Very good. Very, very good. All right, we're going to have 3 videos. The first one is on chemical bond, then ionic, then covalent. Let's check it out. And over here, I have it on a different one. All right. All right. So atoms, when they are by themselves, they have high potential energy. There is going to be a force of attraction that will bring these elements together. The nucleus and the electrons pull at each other, forcing a chemical bond, lowering the potential energy to negative 436. All right. Second one is all about ionic. Let's see. All right. So here you have element sodium giving an electron, right? Moving an electron from sodium to chlorine, making electrons, making chlorine an anion, right? Because it has gained an electron, making sodium a cation because it has lost an electron. And there is an electrical attraction that brings these elements together. Sodium is positive, chlorine is negative. It's saying, oh, pretty. And they're combining. Okay. The third video is a covalent bonding. Covalent bonding. Remember, covalent bonding is in which nucleuses share electrons. All right. So hydrogen had 1 electron. The other hydrogen had 1 electron. Oxygen needs 2 electrons. So it's going to share. Yes, I'm sharing. I can see it on my video. Can you not see it? These orbitals are overlapping because the electrons are being shared equally between these 3 atoms. Yeah, I'm sharing. Everybody else can see? Can everybody else see the video over here? I can see it on my extra computer. You guys should be seeing it also. Okay, that's fine. Okay, yeah, go and come. That way you can maybe you could fix it. All right. So electrons for hydrogen, the 1 electron that hydrogen brought will share between these 2. For this one, the same thing will happen. The electron that it brought will be equally shared between oxygen and the lower hydrogen atom. Okay, just like the one on the right side will share with oxygen uh, its electron. Okay, almost done. Almost done. Three questions, and this ones are easy questions, guys. Really easy. All right. It says use the electronegativity values below and predict which atoms will be more electronegative. More electronegative. Which one has a higher electronegativity, right? Whichever atom, and remember, fluorine is the strongest. So whatever element is closer to fluorine, that is the one that will have a higher electronegativity. All right, so you're to compare sulfur and hydrogen. Well, everybody knows the symbol for hydrogen is H, so that's element 1. It has an electronegativity of 2.1. Now, my question is, do you know which one's sulfur? What's the symbol for sulfur, guys? What is the symbol for sulfur? Is it element 16, S, element 34, Se, element 50 or 51, Sn or Sb? What element is sulfur? And I'm going to leave this right here and see if you can find it. What element is sulfur? What's the number of the element? What's the atomic number? Very good. 16 is correct. Thank you. So we're looking at this element over here versus hydrogen. And we have 2.1 and 2.5. What is your answer? Sulfur or hydrogen? Which one is more electronegative? Which one is more electronegative? Which one is higher in electronegativity? Has anybody picked an answer? Nobody has picked an answer. 1 out of 5 have picked an answer. One person said sulfur. Anybody else want to vote? Anybody else want to vote? Vote, vote, vote. Anybody need to vote? And I'm not talking about the presidential election. I'm talking about sulfur or hydrogen. Is Alexia the only person in the pair deck or what? Who is this? I don't know who this is, but they're the only ones answering. I have 5 students in the pair deck. Wake up, guys. So that's Alexia. What about everybody else? Oscar, Melissa, Mario, are you there? Are you there? Or you're 2 people. There you go. Very good. That is correct. It is sulfur. Now it says predict the type of bond form. So I need to subtract. I need to find the difference in my electronegativity. So if I have 2.5 minus 2.1, what is the difference between those two numbers? If I subtract 2.5 minus 2.1, what is my answer? Get your calculator, guys. Get your phones and start typing. What's 2.5 minus 2.1? And you can type it in the chat. Okay, very good, Yalexia. Very good, Oscar. So is that an ionic bond? Is it bigger than 1.7? Hold on. Let me see. Let me go over here. Is that an ionic? Is that a polar covalent or is that non-polar? If it's 0.4, where are you going to end up on this scale? Is it ionic? Is it polar covalent? Or is it non-polar covalent? Is it between these two numbers, these two, or these two? So what type of bond is that? Very good. Polar covalent. It's gonna look uneven in the cloud. Very good. All right, next one. What if you have sulfur and cesium? Which one is cesium? Is it Cl 17, 6, 24, 20, or 55? Which one is cesium? We need to figure that out first. Which element is cesium or cesium? Element 16, element 6, element 14, element 21, or element 55? What is cesium? All right, now that we know where it's at, let's go back to our presentation. 55, look at that value. Very, very low, 0.7. Which one is more electronegative? Well, that one's easy. Which one's closer to fluorine? Papitas, right? And let's look at the responses. Cesium is closer to fluorine, F. Cesium over here is closer to fluorine, element 9. Thank you. Be careful, guys. Sulfur is correct. Now, what type of bond will that be? If I subtract 2.5 minus 0.7, what do I get? Will I get an ionic bond, a polar, covalent, or a nonpolar? Where will I end up? Ionic. Very good. The electrons are practically transferred from cesium to sulfur. All right. One more question. You see, you guys are so much smarter than my other group. Oh man, I wish you would have been here. If we compare sulfur to chlorine, sulfur, element 16, to chlorine. Which one's chlorine, guys? Which one's chlorine? Element 17, right? So if I compare these two, which one is more electronegative? Sulfur or chlorine? Element 16 or element 17? All right, very good. Chlorine. Nobody responded on here? Okay, either way. Okay, there you go. Chlorine. Excellent. Now, if I subtract, what if I subtract 3.0 and 2.5? What will I get? Will I end up with a nonpolar, a polar, or an ionic bond? Very good. Polar covalent. Excellent. Great job, guys. And I think we're done. And I think we got all the answers. Sulfur, sulfur, chlorine, polar, ionic, polar. We ended up with the same answers. Very, very good. Very good, guys. All right. We are done with the pair deck. Thank God. I need to get out of here. I am depressed because of last period. Oh my God. I can't even type. That's how depressed I am. Oh, pisses me off. Alrighty. All right, let's go to yesterday's topic or the work. Okay, so it's the same thing. I have just added the exact same thing. We're supposed to be talking about Tuesday. All right, not Monday, Tuesday. Let me stop recording.